Welcome to a new video in my home automation series, and today I want to round up my videos I did about solar inverters and Grovat, especially about the unit that I built, which is an ESP8266 with an RS485 converter, which converts the Grovat data, which is Modbus data, which is coming out of the Grovat inverters, and converts it into MQTT, because I wanted to monitor my solar setup. I wanted to be able to gather my own data. Because these are relatively older type inverters which don't have built-in Wi-Fi and data acquisition part of it. I mean, you can purchase it separately, it's a separate module, but I just have the inverters, and because it has Modbus and I know how to use Modbus, I thought I'm just going to bring my own homebrew solution. So finally I finished that. I'm using the exact code that I did the videos on. So there was an initial video and there was another video where I finalized the code, and that code is already available on GitHub, and it hasn't really changed since I released the video. So I have all these units built and installed, and they are collecting data to my InfluxDB database, and I have some monitoring within Node-RED, and also, well, actually I have the whole data collection managed in Node-RED, and then there is also some additional functionality in Node-RED that I want to talk about. So it gives me various notifications once the the inverters go online, and once they finished for the day, I get a summary of the total generation for the day. And of course, the whole thing, it goes into InfluxDB, and I'm just using Grafana to get this information out, which you can see in the beginning of the screen. So I want to talk about all these different bits and pieces, so you can learn, some of the Node-RED stuff. And I played around with these Grafana charts quite a bit. So there are some interesting, InfluxDB queries and some Grafana probably tricks. Well, they were tricks for me, maybe they are not tricks for you. So probably there's going to be a lot of learning here. Otherwise, I'm guessing it's going to be a long video. So just pick the, the part that interests you. Otherwise, you can stay here for the whole story. So let's get started. I think before we start, I want to talk about the solar setup. So my solar setup started back in 2014 with a single phase 3 kilowatt inverter. And in the past couple of years, the regulatory framework has changed a lot, because for any new generations, they are mandating 3-phase inverters, not single phase anymore. So the 3-phase inverter gotten a little bit more expensive. The single phase inverters are getting really cheap because nobody wants them anymore. And there is also another thing, that if you manage to keep your DC cabling under 5 meters, so basically the distance between solar panels and the inverter, you don't have to install a separate DC disconnect switch. Therefore, I wanted my new solar panel, or the inverter is really close to the panels, and I don't have any more space on the roof where I have the existing 3 kilowatt. There is another part of the roof which is quite well apart from the existing setup. So I thought what I'm going to do is just leave the existing 3 kilowatt setup, and I have another 3 kilowatt single phase setup. So the inverter was cheap. I could place it close to the panels, so the installation was simple. Everything looked like this is the proper solution. So I just got another 3 kilowatt inverter from Grovat, which is one of the newer products. Otherwise, I guess it's pretty much similar to the old one. I mean, yeah, the Modbus is different because they are using different registers, and I guess they have retuned the software in the past couple of years. And then, as I was just doing the paperwork, I realized that the law has changed. I mean, it was my fault, because I started the whole planning and installation before I actually done all the paperwork. So the company told me that I have to ensure that there is no phase difference more than 2.5 kilowatts, which means that I was feeding 3 kilowatts into 2 of my 3 phases, and that was not acceptable. So hence I needed a third single phase inverter just to cover the difference. So at the end, I have purchased a 1.5 kilowatt inverter from Grovat. So that's a smaller one. That was the smallest one that was available, and I got 4 more panels to match that. These are new Canadian Solar, I think 400 415 watt panels. So 4 goes on to the 1.5 kilowatt inverter and 8 on to the 3 kilowatt inverter. So this is why I have like now 3 inverters. And hence you can see the 3 graphs or the 3 lines in the graph. And also there was really limited space. You can see in the videos that on the second inverter, so the small inverter, I was happy that it is smaller because there is a really thin cabinet that it all had to fit in, and the new 3 kilowatt inverter just wouldn't fit because it's just, you know, thicker than the old one. So that was one of the reasons why it has gone into the garage. So now I have the new one in the garage alone, and that has its own small, you know, box which is reading the data of Modbus. And upstairs in a cabinet I have the old one sort of like at the bottom of this whole cabinet, and we managed to find just enough space for the small inverter and some of the, you know, the DC and the AC side of you know, sockets and disconnects and fuses and switches. And for those there are actually 2 small ESP units. One is reading one of the inverters and the other one is reading the other. And in the AC side box I managed to fit a 5 volt mean well power supply, like a DIN mounted version, and that's just feeding the 2 ESPs with, you know, 5 volts power. And that's pretty much it. So as I mentioned in my previous videos of the, you know, Grovat to MQTT inverter, or sorry, the code, that it is actually pushing all the data into MQTT. And actually this is the flow that I had for my previous setup, and probably in some of the videos you could see a Raspberry Pi 1 just next to the electrical cabinet, and that was the old data acquisition process. So I found this Python script online which was running on this Raspberry Pi, and that was reading the data of the old inverter and publishing that into MQTT and also into pwoutput.org. So that has been decommissioned. It's still there, I just disconnected it. So that was the old code for that, and well, this is the new code. And as you can see, everything is 3 times because I have 3 inverters, 3 of the MQTT boxes, and so I'm handling the whole thing 3 times separately. And actually, let me just start the MQTT Explorer. The units are running 24/7, so I haven't really cut the power from to them. I was actually thinking that I'm going to power these MQTT boards off the inverters, because in one of the documentation it seems that there is like a 12 volt output on the inverters, but I couldn't really find that, and I just didn't want to poke around with the, you know, the terminals. So I thought, okay, it's going to receive separate power, which means that they are online all the time. So you can see that they are just feeding into the Grovat topic. So I have a small, which is, sorry, a garage, that's the 3 kilowatt in the garage. There is the small, which is the 1.5 kilowatt, and there is the old, which is the old inverter. So they are, you know, sending the same data, and even now, even when the inverter is off, they are just sending data, you know, status 0, which is for Grovat. It means that it's not working. And I'm actually a little bit puzzled because I always had this idea that when there is no DC solar power, then the inverter actually shuts down completely, because this is how it uses the solar power to power itself. But because I'm still getting Modbus data, it looks like that it actually uses the you know, the AC side. So yeah, but anyway, so even now I'm getting some data, at least I'm getting some data from the garage inverter, but not from the other 2. Regardless, when the sun is shining and the unit is on and it powers itself on, it starts sending the data, or it makes the data available in Modbus. So then my unit just keeps sending it, and it sends it like every 10 seconds, or even, you know, quicker. It depends on the code. So essentially I'm getting something like this. I don't want to spend an awful lot of time on this because I've already explained the data structure in my previous video. Probably the only difference is that in the old inverter, it doesn't have the same level of information, so it has slightly fewer temperature readings, and I think in the In the new inverters, there is a derating setting. So maybe if there is too much solar power, like DC voltage, or there is too much temperature, then the unit can derate itself. So it reuses the generation in order to, prevent overheating or overcurrent or over voltage. And that's actually something that I'm quite looking forward to see if that happens. But that's not available in the old inverter. So for the older version of the Grovat, the data structure is slightly different because I'm not getting so much data. But anyway, regardless, the two is working the or sending the same amount of sort of like main data that I'm interested in, like what is the total generation, what is the today's generation, the voltages, power output. Yeah, I think these are the key ones. And of course, like status, whether it is running or it is ramping up in order to synchronize with the AC voltage and the frequency. So this is what I'm getting through MQTT, and it all goes into here. Let's say this is the garage, and actually there's two different topics. There is the data topic and there is a status topic, which is just the status that the ESP is running. I'm monitoring that in order to tell me if there is anything wrong with the ESP, like if it, let's say if it gets stuck for any reason and it needs to be restarted. So I know that this status message should be coming every minute. So if I'm not hearing any status message for like 5 minutes, then it sends me an alert that the ESP appears to be offline. This code has been running for probably about 2 weeks. And as I said, the ESPs are running 24/7, no issues so far. So technically this code, I mean, this is the same code that I'm using for pretty much all my ESPs. And it is just, it remembers what was the last time it received the message. And then if the time passed since the last message is more than 300 seconds, so that's 5 minutes. Okay, then it says that the device has gone offline and it sends me this message. And I have this whole framework within Node-RED that I explained in a very old video, how I manage systems and system statuses, how it logs all of this information and then sends alerts to Telegram. So it keeps this information, and of course, if it notices that the device is offline, but then it receives a message, then, well, it knows that the system has come, or the ESP has come back online. So he will manage the system disappearing and coming back online. So that was the status part of it. And then we also have the data section. And in this data section, it's doing pretty much 3 different things. First of all, I'm saving the data into InfluxDB. Okay, actually, no, that's probably 4. So I'm saving the data into InfluxDB, and as you can see here. And then I'm also saving the data into pvoutput.org. So that's the service that I was using for a long time for my old inverter, and I wanted to keep all my new inverter data in pvoutput.org as well. And then it also keeps me updated on Telegram, especially about those phase changes, like when it comes online, if it goes online, if it for any reason goes to derating mode, which haven't happened yet because it's winter, so it's cold and we don't have any sunlight to even hit the peak generation or the peak PV thresholds. So that's probably something that I will see in the summer, if I see it at all. And also the code makes sure that the actual generation or the data collection is running. So every day at 10 a.m. it would check in the InfluxDB database if there is data for today, because it is possible that the ESP is running, but there is no data coming from the inverters for any reason. So that sends a separate alert. And lastly, there is a node in here as well, which that's for daily stats. So again, I wanted to get a notification at the end of the day how much it got generated. So as you can see here, today I got 11.5 kilowatt hours, and that's from the three separate systems combined. So it's basically just looking at the data, and if the daily generation goes below a certain threshold, like I think 10 watts or something like that, that considers that, you know, all the inverters are now offline, and then it just sends a Telegram message. So first of all, when the data comes into the data topic, I included this switch because when I store the information in InfluxDB, or when I store the information in PV output, I don't care about any data where the generation is already stopped. So I'm saying that if the output power is more than 0, then okay, let's store the data because that's valid solar generation. And the ESP itself sends data very frequently, and I said, you know, for InfluxDB, I don't care anything more frequent than 1 message per second, or one data per second, and for pvoutput.org it's every 5 minutes. And also keep in mind that the inverter is aggregating its own generation for the day and for the total generation. So I don't really have to do any addition either in the ESP or in Node-RED, because I'm just reading what the inverter tells me. I mean, I'm sending to pvoutput.org and also InfluxDB, I'm storing the actual generated power, as in what is the current generation or wattage. And of course, that would be just a snapshot of that particular sort of like second, which wouldn't be indicative to the last minute or the 5 minutes. But yeah, that's something. So I'm doing this filtering just by using a delay node, and here I have this add text node because there is a lot of like status flags or registers in the Grovat about like what is the current status, whether it's generating, it is at fault, or it is waiting. If there is, as I said, there is this derating mode, what is the reason for the derating mode? So as you can see, for example, the temperature is over a certain thresholds. There is also various fault codes and other fault codes. So the raw data comes off from the inverter, and I'm just creating these text fields so I can store it and I can show it in the, for example, in the Telegram message, which you are going to see later. And then finally, when we have all the information, I create an InfluxDB data point. So I create a record. So this is the type of record that you need to send into InfluxDB. I think I've already mentioned about this in various previous episodes. So you have to send in a record which is an object, and it has a couple of properties. So it has measurements, tags, and fields. So obviously the measurement is called the solar for me, and then there is only one tag, which is the inverter. So whether it's the the garage, the old, or the small. And then basically everything else goes into fields. And I'm not really sure I'm going to use all these fields ever, but I thought, okay, I have this data, I'm just going to dump it into InfluxDB. So there is a bunch of different fields about all the generation and the power and PV voltages, energy for today, energy total. And also at the end, I'm also adding these text fields as well. So everything gets stored in InfluxDB. And you have to set, or you have to add these records into an array. As you can see here, it's the data array. So I'm pushing this single record, and that's the payload which goes into the Influx, I think it's called the Influx batch, which I have on the, sorry, is this one, which I have on the very first tab. And I'm just using this link out. So it just goes into an Influx. You can probably see it here. Sometimes, okay. Sometimes these links are not working the best. So it's this one, and it is called the Influx batch. where you configure your InfluxDB, you specify your organization in the bucket, and yep, then the information gets stored. So that's all about storing the data. And then I also create a pvoutput.org update. And if I make it full screen, you can see in the code that there is the API for pwoutput.org. You have to provide your API key and the system ID. So the system is your PV system. And then you have to send a couple of parameters. There are a lot more parameters that you can send in, but I think date and time, so DNT is mandatory. And then you see there is V1, V2, V5, V6 that I send in. And there is an M1, which is the weather condition in a text format. Like, you know, if it's a cloudy weather, what's the temperature? I mean, you can send in whatever you want. And so V1 is the energy today, output power is V2, and then the current temperature, which I'm getting from an outside weather sensor, that goes into V5, and V6 is the PV voltage. So for this inverter, it is connected to the second string. So this is PV2 voltage. So it is, I think, a simple HTTP GET request, yeah, which goes to that service. And that's it. And it saves into PW.org. By the way, this is how it looks like. So this is my old inverter. And if I go into yearly, then you can see that it is, you know, pretty much logging since the inverter was installed back in 2014. So it's quite nice. And we have a little bit of 42 kilowatt hours since the beginning of January. And for this Telegram logging, I'm just going to include a screenshot how it looks like on my Telegram account. And what I'm doing here is I'm putting this string together which says, okay, the garage inverter status, and it includes the status underscore text. So that says whether it's waiting or fault or normal mode. And there is a derating mode, and it also includes the fault code and the warning codes. And it creates this for every single time a new message comes in. And I just have a very simple filter node which says block values unless it changes. So that basically just, you know, it just gets bombarded with data, and then it lets probably 1 or 2 data through once a day. So this is when it changes from, you know, fault to normal. That's when it starts ramping up the generation in the morning, and it does the opposite in the evening when there is no more sun left, and then the inverter shuts down. And I just get these messages, and I'm using the Telegram alerting, or what is it, system subscription functionality, which I built again a couple of years ago. I have a separate video on that. And you can also see the sample text here. So I'm just getting like something like this. So garage inverter status status waiting. That's when there is not enough sun anymore, and it sort of like disconnects from the AC network. I think there is like a voltage threshold. So if the PV voltage is less than 120 volts or something like that, then it goes into waiting. Of course, thinking that the sun might come back, but of course it usually doesn't. So that's the text that I'm getting at the end of the day. And that's pretty much it. So that's what happens for each of the 3 inverters. And I also have these daily tools, which, as I said, it does a simple calculation. Obviously, it remembers the power, the total for each of the inverters, and it just creates a sum of them. So it creates like a total output power, energy today, and energy total. And finally, if I have okay, that also gets smoothed for the last few readings. Oh, over the most recent 100 values. Okay, this is 100 because that happens like every 10 seconds. And then also I have a simple function node here which says, there is an on and an off threshold. So consider the inverters to be on if they are generating more than 100 watts, and consider them off if they are generating less than 10 watts. And if they are generating less than 10 watts, again, I get a message on Telegram that today we have generated that much power. And probably I will keep this running for a couple of months until I get tired of it. And finally, the last bit of code is checking on the generation, just making sure that it is actually collecting data, and that runs 10 a.m. every day, assuming that by 10 o'clock, even if in the worst days there is some generation. And I'm just running a very fixed query, which says, select from the bucket Node-RED for the last 4 hours. So that again, just covering anything that is generated for today. For the measurement solar, the inverter old, and I'm just looking for the field output power. And of course, if there is no data available for that last 4 hours, then I will be getting an empty array. And if there is any data stored for the last 4 hours, then those data points will be in an array. So all I'm doing here is checking how much entries I have in the array, or how much elements I have in the array. So if it's 0, it means that we don't have any data. So something is wrong. So either the inverters are off, or maybe the data connection is broken. It is not able to read over the Modbus. And again, I'm getting a separate message saying that there is no data collected from the old solar today. And the same happens for the other 3 inverters as well. So this is just maintenance, just making sure that everything is working fine. And actually, since we are here, I thought I'd just show you how this all looks like in InfluxDB. So it's not really complicated. So I go into the Node-RED. So this is my new bucket where I collect my good official data. My DB was more like a test database playing around initially. So there is a solar measurement, and it has a single tag which is called the inverter. So it can be either garage, old, or small. And then if I select that, you see all these fields. So everything that comes through the MQTT, basically every register that I collect, with the additional text fields as well. And let's say if I do energy today and for the past 30 days, okay, let's do just past 2 days. Okay, yeah, so this is how it ramps up. And then, as I said, the inverter collects or accumulates the generation automatically, so I don't have to do anything. And then there is no data from, that was like 4:10, and the next data is next day 7:40, which starts with 0, and then it starts ramping up again. And let's see how it all looks like in Grafana. So I wanted a few things in Grafana. Obviously, I wanted like totals, like, okay, how much my whole setup is generating. Of course, it shows a really high value now because the oldest 3 kilowatt inverter is running for, 7 years now. So you can see that it has generated 17 megawatt hours so far. And that's basically just the old inverter, and the new setup has done, just a few kilowatt hours. And that is really easy to see because, as I said, that energy total field is getting accumulated by the inverter. So all I have to do is I select data for the last 24 hours, because if all the inverters are running, I'm pretty sure that I have some reading for the last 24 hours. So I select the solar, I select the field total energy. So that would always have like 3 sets of entries for the 3 inverters, assuming that everything is working fine. And I just select the last, so that would give me 3, and then I just group them. And here in InfluxDB, I can select the calculation total. So it automatically adds all of these values together. And yeah, I total the underscore value field. And also here I can specify, I think I did, well, I'm pretty sure that I've specified, did I? No, I didn't do overrides because it's only one value, but yeah, I selected the unit of kilowatt hours, and then it automatically converts it to megawatt hours because then it would be such a high number. So that was simple, and it's pretty much I could do the same for the the generation for today. I'm just using the energy total field, again last, and I just group them. And also the inverter keeps track of how long it has been running, actually generating power. That's the total work time. And then again, I just last and group them. And here I could specify that the value is seconds. So then it automatically calculates how much is that in years. So that Grafana does that. So the next bit I wanted to add is the just a snapshot of the generation today. And this is a very complicated query because I wanted to do a lot of stuff in here which I couldn't do. And I couldn't do because that's not, I mean, Grafana is not designed that way. What I wanted to have is when I come to this graph, I wanted this part, so this chart, to automatically zoom in on today. And I couldn't do that. So it looks like that in Grafana you can specify these filters, and you can also make certain charts to automatically select a certain time period, but that time period can be only a period up until the current time. So you can say that this should always show me the last 24 hours. But I wasn't really happy with that, because if you only show the last 24 hours like you see here, you always have this huge amount of blank space, because you would never get a generation in the last, even in the best, in the last 6 hours. And of course, even in worst cases for the last 4 hours. So what I wanted to do is I wanted Grafana to zoom in on the period when we have actually data. And this is why if you remember back in Node-RED, I added this switch node to only store the data where the output power is greater than 0, because I didn't want to have a lot of flat lines in my database, storing unnecessary information, and of course that will show up in the reports, in the graphs. So at least when I can see that there is some graph, it means that there is actually generation. And I was thinking that maybe I can do that in Grafana, in InfluxDB, but then it turned out that I couldn't. So I actually raised the ticket on this on the on the Grafana forum, and I was told that it's just not possible. So what I wanted to do is I wanted to calculate the start time. So that's basically the first reading that comes in for every single inverter. So first of all, I created a query where I select from Node-RED. I select for today the solar measurement and the output power field, and I would group these values because obviously I have 3 tags, and I would select the first one, and I needed to group the values again, and I have to use this table, find table, to actually find a particular field which is called the output power, and I get the first record. Because so I was playing around with this a lot to make this work, because I thought I only have to do this much, and I put it into a variable, and that would be the start time. But then again, it didn't work. I asked in a forum, and I was told that I actually have to use these functions as well, because whenever you return something from InfluxDB, it is returned as a table stream. And in my previous video, I talked about how the information comes in a table stream which actually contains multiple tables depending on the keys. And the key can depend on, let's say, the different, for example, the different tags in my case. And first of all, I had to combine them into a single table, and this is what this function does. So just to make sure that it is a single table. And then in that table, I have to find a particular field that I'm interested in. And even though I did a first here, which would ensure that I only have 1 record left, but still I had to issue this statement which gives me the first record. So that would give me the first record when the first reading started. And then I calculated the same for the end. So it's pretty much the same as above. The only thing is it's not first, but it's last. So that again selects for the last 24 hours. Sorry, it selects from today, so from midnight today. And then it will look at the last data that has been recorded, and then it picks the timestamp for that. And then I run a selection where I get the data start time. So that's the record. So start time is actually the record for the first reading, and the end time is the record for the last reading. And for every record that comes through InfluxDB, there is an underscore time, which is the timestamp. So now I can run a selection where the range says start time dot underscore time and end time underscore dot underscore time. So then we are selecting the data from the first record to the last record. Unfortunately, it doesn't make a huge amount of difference, because even if you select today, because I'm not storing the data before and not storing any data after, I'm not getting more data anyway. I was just hoping that by specifying the range here, Grafana would be smart enough to zoom the view into the data that got selected, but then I realized it doesn't work that way. But it was an interesting experiment how you get data. For example, how you get a specific data from your database and use the time of that data to run another selection. So if you need to do anything like that, then you can use this method. And as I said, the key is this find table, while making sure that the selection only contains a single table. So the data stream only contains a single table, and then you can use the find table and the get record to get a specific record, for example, the first record. And then you can just reference to the timestamp of that record with something, dot underscore time. But regardless, I think it's a nice graph, and I just specified a couple of overrides where I could pick out these output data, and I could also rename them. So it shows like, garage inverter, old inverter, and small inverter. And also the value shows as kilowatt hours. So for each of the three data points, I specified an override, and I specified color, the name, and the unit. And the reason I specified colors, because then I use the same color scheme. So as you can see here, the garage inverter got yellow. So when I go into the details, everything is yellow here. And then for the other inverter, everything is purple and then blue. And if I scroll down from this today's generation, you can see three groups for the three inverters. And I'm just getting, basically everything from that inverter. So all the meaningful values that can be shown, I just basically put into this graph. And here there was also a little bit of trick involved. As you can see, I'm filtering on measurement solar. Again, that shows the garage inverter, so I'm specifying here that the inverter is garage. And I also included an additional filter where I have specifically listed all the fields that I wanted to include in the graph, because if you don't do that, all the additional fields show up here. And even if you don't create an overrides for them, they show up in their default name and field name. So if you don't want them, you basically just have to say, only show me these fields, only include me these fields, and you have to have them in the Influx query. So, restricting the selection to only these fields. And I also had an aggregate window, which I removed. So maybe if you have, too many readings or your selection is running too slow, you can include that, because, technically for that timestamp, having a reading every single hour, I don't know if it actually fits on the screen, like in this magnification. And of course you can focus on, single readings, and it hides the others. And I included all the units, so we have a couple of, Y columns here, and one more here. And I'm also getting the the current values. So that basically just picks the last values from, let's say, the status text, or the rating text, or the energy today, or the lifetime, or sorry, the energy today, energy total, and the work time. And then the same goes for the small inverter, and then the same goes for the which one is that? This is the old inverter. So I'm getting the same stuff. There's slightly few data series here because of the, as I said, the old inverter has less information in Modbus. And finally, an interesting graph, which I managed to do completely in InfluxDB, is to add the three inverters together. So this is the total generation. That's basically the sum of these three graphs. And it's quite interesting to see how smooth it looks with the three inverters running, even though they are slightly in different locations. One has a little bit of shadow, especially in the winter time. So you select the data for the time range and for filtering on the tags, the measurement, the tag, and again I'm just using output power, and I'm using a 5-minute aggregation window here because I cannot guarantee that the readings are coming exactly the same for each inverter. So this is why I'm using a 5-minute aggregation window, because each of these selections have the same start and stop, which comes from the filter, and therefore the 5-minute aggregation windows would have the exact same slices and the exact same timings. So that was the only way for me to aggregate them. Maybe if you want more data, you can bring this down to maybe 1 minute or 2 minutes, but I thought 5 minutes should be fine. So once I have the data from the 3 solar panels, then I create a union, which basically is going to bring these separate readings into one table. And for the rest, for us to better understand, I actually have to copy this into InfluxDB, because I think it makes more sense if we see what the data looks like. So let me just switch to the table view, and I replace that, and I start commenting out everything here. Because then it's just going to make a lot more sense. So if I just union the 3 tables, then as you can see, in the table stream, I'm getting 3 tables. And the difference between is obviously the tag is different, because one has a garage tag, the old and the small. So, but I'm still getting time and the value, and the field is output power, and also I have the measurement here and the tag. I mean, yeah, measurement is always going to be solar. So first, I'm using a pivot, and I'm still struggling to understand how the pivot works exactly. It kind of makes sense, but then when I try to use it, I always get confused. So it is called pivot because, if you're using pivot in Excel, probably it makes sense that it is named the same way, because it is about transforming the data based on a common value. And so here the common value is the row key, which is _time. So that's going to be the rule how the InfluxDB is going to create the new records. And then the columns is the columns that it should keep for each of those times. And the value is the actual value that should appear in those columns. So if I just execute with this pivot, then what we are going to see that we still have the 3 tables for the 3 inverters, and we still have measurement, and then the inverter remains like this, but then we are getting an output power column. So instead of the field and a value, now we are getting a column which is called our field, and the value is the actual values. So this is why, this is field and this is value. So that's the field, and then the values in that, if it makes sense. So now the data almost looks like what I need, because I have the inverters, and for that I have the values, but I'm still getting 3 tables in the table stream. So if I just group them, then I get a slightly different table now. So at least what I could do now is I can get into a table stream where the individual tables contain the readings for the three inverters for the same time. So as you can see, at 8 o'clock, the garage was outputting this, the old was outputting that, so, and this was outputting that much. So I managed to now sort of like, not transform, but in one table I have the data for the three inverters for the same time. And I could do another pivot where the row key is again the time, because yeah, I'm always interested about the time. And now the column is the values of the inverters. So I want a column which contains the garage, the old and a small. And so now I can do that because I have it in as values in different, sorry, not values, but values of a, yeah, values in a different, in different cells, as I would say. And then the value column is going to be the output power. So the output power will be the value. And if I execute this, you're going to see it's going to make absolute sense. So now I can see that, for example, 7:30, the old inverter has generated this much. And if I start scrolling down, you can see now that for 9:45, the old has generated this much, the grass has generated this much, and the small has generated this much. And the reason I didn't have, for the first table, I only had the old because that was the first inverter to start up. So for that same 5-minute window, I didn't have data for the other two. Okay, so now what happens if we have multiple tables in a table stream and we want to get them into a single table? We just group them. So I group. And the result is, finally we are getting one table in the table stream, and it has the time that we need. It has 3 columns for all the 3 inverters, and yeah, it looks good. And why is it scrolling so slowly? Anyway, so this is how the data looks like, and as you can see, depending on when one of the inverter is no longer working, we are also getting some null values. So what we need now is we just need to add, we just need to create a new column where we add all 3 of them together. And actually we can do that in InfluxDB as well. But before we do that, we have to do a small thing, which is converting these null values into actual zeros so we can add them together. And you can do this with a map function. So you say that in this map function, the R is your whole record. So with the garage field, if the r.garage, so the actual value exists, then the result is itself, otherwise it is 0.0. So again, if I submit this and if I scroll all the way down where we could see the null values before, now we are seeing zeros. And then finally I can create one more. Sorry, did I do that already? Oh yeah, I did that already. Now I can create a new mapping. So in the mapping you can actually create new fields as well. So r_vid_value. So I could create a new _value field, which is the r.garage plus the r.org plus the r.small. And that's what you see here. So that basically calculates the sum of these 3 fields together. And then for this particular graph, I don't need the individual inverters anymore, so I can just drop the garage, the old and the small. So that gives me a table where I have the time and I have the value that I need. So I can go into InfluxDB and I can just create a simple graph, and I could also create an override where it says the _value is a combined generation. You can see it here, and then it's going to be watts. So, and then I have the, the final graph that I needed. So this was, I mean, it took me quite a long to create this one, and I think Part of this query also ended up in one of the discussion in the InfluxDB forum. So the guys were kind enough to help me on this. So this is where I'm at the moment, and it has took me quite a couple of weeks to get to this state already. I think the generation and the data collection was already running by the time I managed to get into sort of get all these graphs working. And as I said, I had to ask a couple of questions on the forum. And I mean, sometimes it's just interesting to see how, probably the shades and the difference between the old like a 7-year-old panels and the brand new panels, how much different it makes in between, how each of these setups are generating. And as you can see, in most cases, for example, if I look at this one, the difference between a 1.5 kilowatt inverters compared to the old 3 kilowatt inverters is the same as between the old 3 kilowatt and the new 3 kilowatt inverters. So I'm pretty sure that maybe not the inverters, but I think the panels do make a lot of difference. And this is how much the technology has evolved in the last couple of, last 7 years. I mean, that's a lot of time. And maybe if I manage to run this for a long enough period, maybe I would be able to tell if the solar panels indeed degrade that much that it is noticeable in the generation. Because if I, for example, look at this graph, it doesn't look like it. It doesn't really look like that it has consistently dropped in generation, because it looks pretty much the same for the last 7 years. And my data acquisition hasn't been done maybe for the occasional day. So it is actually showing me the generation for those 7 years. And as you can see, it looks, I mean, of course there is some not seasonality, but maybe there are some better years and worse years, but it's definitely not going down. Not something that you would notice anyway. I think this is where I'm going to end this video. I am not planning to make all these, the flows and the whole Grafana public. I think you could see already most of the queries just by, looking at the video, and maybe you can just pause, you can write them down. If you need any of these specific, just let me know in the comment section. I can just make them available, but I don't think it's, I mean, it's really specific for my case. I thought it was just more an interesting learning than something that you can just grab and re-implement yourself. I mean, hopefully you don't end up in this situation that I did, that you have 3 separate, solar inverters. I'm hoping that you have like, one bigger 3-phase inverter which can handle multiple strings, and you don't have to do all this addition and comparing, because it's all going to be done by the inverter itself. So I think that will be all for today. Thanks for watching, and hopefully see you in the next video.